Hello everyone. In this video, we'll talk about the rotated coordinate system. So first, we'll take our initial coordinate system or standard coordinate system. Let's say x and y is in our 2D coordinate system. Okay. So in this coordinate, one point is there. This point is 2, 3. So what is the meaning of it? That means I have to go along x-axis by 2 divisions. Then I have to go from this point. I have to go 1, 2, 3, and ultimately I will reach this point 2, 3. Now, this is with respect to the coordinate system, that is the initial coordinate system or standard coordinate system. Now, let's say I have rotated this coordinate system by some angle theta. So, if this entire coordinate system is rotated by some angle theta, then this x-axis will no longer be lying like this horizontal. So, this x-axis will be rotated by angle theta, and now the new coordinate or new x-axis will be x dash axis, and at the same time y-axis will also be rotated by angle theta. This is, let's say, y dash. So initial coordinate system is x and y, it is shown in yellow color, and the new coordinate system I have rotated, that is x dash y dash, that is shown in green color. Now, with respect to our initial coordinate system, or 1, the coordinate of the point, let's say P, the coordinate is 2, 3. That means I can go 2 unit in x direction, 3 unit in y direction in order to reach this point. Now, what will be the coordinate of this particular point with respect to our new rotated coordinate system? Because with respect to our rotated coordinate system, we cannot tell that this coordinate is 2, 3. Because if I go 2 unit along x dash axis and 3 unit along y dash axis, we will not be able to reach that particular initial point P. So it is clearly visible that with respect to our new coordinate system, the coordinate of this particular point P is no longer 2, 3. That is with respect to our old coordinate system. So with respect to our new coordinate system, I have to find out what is going to be the coordinate. How to do that? Now, entire coordinate system is rotated by angle theta. So this is theta, means this is also theta, because x dash and y dash with respect to each other, they are having angle 90 degree. So this is angle theta. So how to find out? So in that case, I have to find out x dash in the terms of x and y. At the same time, I have to find out y dash with respect to our old coordinate system x and y. So what is the x dash? X dash is, see, x dash is making angle theta with the old coordinate system, that is coordinate system 1 is coordinate system 2. So the projection of x on x dash, that is going to be x cos theta. X cos theta. At the same time, initial y-axis in the yellow color, it is also making some angle with the x dash axis. What is that angle? 90 degree minus theta. So I can easily write the projection of the old y axis on x dash axis is going to be y into cos of 90 degree minus theta. So you can write y sin theta. At the same time, y dash axis is also having some projection from x, as well as it is having some projection from y, because it is inclined to the x and y. It's no longer 90 degree. See, the angle between x axis and y dash axis is 90 degree plus theta. So I can write that the projection of x axis on y dash axis is going to be cos of 90 degree plus theta, plus it is also going to have one projection of our old y-axis. It is y of cos theta, because the angle between y dash and y is theta. So y of cos theta. So I can rewrite this y dash minus of x sin theta plus y cos theta. Now see, we have got two equations. equation number 1 and equation number 2, where the old coordinate system, or with respect to the old coordinate system, I am getting the new coordinate values. How to represent that? So in 2D space, coordinates will be only having two values, x and y value. So x dash and y dash, I can write like this, a matrix form. This is, of course, 2 cross 1 matrix. Number of rows are 2 and column is 1. It is multiplication with one matrix along with our old coordinate, that is x and y. What is that? That is called transformation matrix. Transformation matrix. Now see, I can write here cos theta, sin theta, minus sin theta, and cos theta. So x dash, you want to find out, just multiply with this row, just do the matrix multiplication, because this is 2 cross 2 order matrix, this is 2 cross 1. So ultimately, they, in the multiplication of this matrix, they will ultimately give the result of 2 cross 1. So x dash is going to be x cos theta plus y sin theta. Similarly, y dash is going to be minus x sin theta plus y cos theta. So I can write capital X dash, that is the coordinate with respect to the new coordinate system, is going to be T, that is our transformation matrix, multiplied with our old coordinates. Okay. Now let us find out, with respect to the new rotated coordinate system, what is going to be the coordinates of that same point P. Let's say angle theta, I have given 30 degree. That means the old coordinate system is rotated by angle 30 degree. Now the new point or new coordinate, then how the transformation matrix will look like? Transformation matrix will look like cos 30, sin 30, minus sin 30, and cos 30. Please observe closely that the determinant of this transformation matrix is always 1. If you find out the determinant, cos square 30 minus of minus sin square 30, so it is cos square 30 plus sin square 30, it is 1. Now, our new coordinates with respect to our new coordinate system, the same point is no longer 2, 3, rather it is multiplied with the rotated transformation matrix or rotational matrix 2, 3. So I have to just multiply with the transformation matrix and I'll be able to find out the coordinate values of the same point with respect to the new rotated coordinate system. So x dash value is going to be 2 cos 30 plus 3 sin 30. 2 cos 30 plus 3 sin 30. That is 2 cos 30 is root 3. 3 sin 30 is 3 by 2. Similarly, y dash is going to be minus of 2 sin 30 plus 3 cos 30. Minus of 2 sin 30 plus 3 cos 30. That is minus 1 plus 3 root 3 by 2. So same point P is right now being represented with respect to the new coordinate system by this coordinate value. So the new coordinate is going to be 1.5 plus root 3, comma 3 root 3 by 2 minus 1. This is going to be the coordinate of the same point P with respect to the new coordinate system. With respect to the old coordinate system, it was 2, 3. Now, this is in 2D. So if I tell this is in 2D, but the actual transformation matrix is 3 cross 3, and any coordinate in 3D is of course denoted the 3 values of the particular code. Let's say 1, the 2, 3, 0, let's say. Same point. Let's say point P only. Now I'm representing it in 3-dimensional space. So the coordinate will be written 2, 3, 0. So if I rotate this coordinate system anti-clockwise, see, you have studied that I cross j is going to be k. So if this is x-axis, is y-axis, z-axis will be outward. That means initially whatever problem I have given or whatever angle of rotation I have given, that is with respect to the z-axis only, 30 degree. Same problem, right? Is there any change in the z coordinate due to this rotation? If you rotate the entire coordinate system with respect to z-axis, is there any change in the z coordinate? No. So the transformation matrix should be same, but right now only it will be 3 cross 3. So this was the transformation matrix we have got. So to make it 3, 3 cross 3. So this is just the transformation matrix, how it will be represented. And x dash, y dash, z dash will be represented as this t multiplied with our old coordinate values. Now, if you want to find out z, see, z is not having any change. Z dash is going to, if you multiply this, 0 into x plus 0 into y plus 1 into z. So z dash is going to be z only. Now let's say same problem in 2D space only I'm giving, 3D we are not going right now. Same problem, let's say this is our initial coordinate system x, y. Okay. And same point we'll take, that is 2, 3, point P. Now if I rotate this entire thing, or entire coordinate system by angle 90 degree, that means x-axis I have rotated by angle 90 degree. So our x dash axis right now is here. And our y-axis also rotated by the same angle 90 degree, right? 90 degree. This is our y dash axis. What is going to be the coordinates of the same point P with respect to the new rotated coordinate system? But right now I have given the rotation of 90 degree. How to find out that? So this is going to be our new x dash axis. This is going to be our new y dash axis. So with respect to that, what is going to be the coordinate? So see, from the geometry only, we'll be able to tell that this is 2, 3. So with respect to the new x dash and y dash coordinate system that is rotated by angle 90 degree, it is going to be, see, this is 2, right? This is 2 unit, this is 3 unit. So with respect to the new coordinate system, I have to go 1 unit, 2 unit, 3 unit. Then I have to go in the opposite direction of the y dash axis in order to reach this point. So what is going to be the coordinate of point P with respect to the new coordinate system? Same point P. See, it is going to be 3, minus 2. Because you are going 3 in the direction of x dash. Then you are going in the opposite direction of the y dash axis in order to reach this particular same point P, 2, 3. So with respect to the new coordinate system, the coordinate is becoming 3, 2. Let us find out using the transformation matrix. X dash y dash is going to be cos 90 sin 90 minus of sin 90 and cos 90 multiplied with our old coordinate values 2, 3. What is going to be the value of x dash? 2 into cos 90, that is 0, plus 3 into sin 90, that is 3. Y dash is going to be 2 into minus of sin 90, that is minus 2, plus 3 into cos 90, that is 0. See, we are getting the coordinate of the same point P with respect to the 90-degree rotated coordinate system, 3, minus 2. So from the geometry also you'll be able to find out, but if the angle value is given different, then this is the best way to find out what is going to be the coordinate of the same point. So I hope it is clear.
And let me tell you that this is a very core basic of robotics, because in order to reach one particular point you have to give the direction via programming to the robotic arm. But once the robotic arm is rotated, whatever data you have given, that becomes invalid after one rotation only. So each and every time for rotation you have to keep on multiplying with those transformation matrix in order to reach that particular point with respect to your absolute coordinate system. But of course those multiplication of matrices we will do by program that we will write.